Bismillahirrahmanirrahim. Today we will cover some of the topics from radiology books. The first one is radiation. What is radiation? So its definition is like this: that radiation is a transfer of energy from one place to another in the form of waves or particles. So that's radiation. It's just a transfer of energy from one place, from point A to point B, that may be in the form of waves or in the form of particles. So that is radiation. Now what's the explanation is? So radiation is energy traveling through space. In radiology we use radiation X-rays to create images of the inside of the body. X-rays that penetrate the body, and for example here we have the bones or some structures that absorb those radiation, and here a shadow is created on a film called the radiographic image that is found here on the radiographic film. Now there we have the ionizing radiation. So the ionizing radiation are the radiations that are the ion making radiation. Ion making radiation. So what's our ion making rays or ion making radiations or ion forming radiations? So ion forming are radiations or radiation which forms ions, These are the type of radiations that has enough energy to remove electrons from the atoms and create ions. That can create ions. So these are the ion forming radiation. For example, here we have array, and that here we have the atom. This is the nucleus, this is the electron, and here the ray has this electron, and this electron is ejected from this atom. So an ion is formed and the electron is ejected. So these are the ionizing radiation. Now the explanation is like this. Here we have the when radiation removes electrons, it changes atoms. X-rays and gamma rays are ionized. It can change the atom, like it can convert the atom into an ion. That may be the cation, or the anion. The cation is the ion that have the positive charge, and the anion is the negatively charged species. So here the X-ray and gamma rays are this ionizing radiation. That's why X-rays are harmful and gamma rays are at most harmful. This property allows X-rays to create images, but also means excessive exposure can damage tissues, because these are ion-making radiation and can ionize tissues. Then we have the EM radiation. So what is EM radiation? EM radiation refers to electromagnetic radiation that travels as well made. EM radiation consists of beta, that is the magnetic field, and electric field, so that consists of two fields. These are the EM rays, and they can travel to space. They can travel to space and don't require any medium for its travelings or its traveling. The explanation is it includes radio waves. Then we have the EM spectrum. The EM spectrum have many waves, like we have the radio waves. Their wavelength is very big wavelength, and then we have, and frequency is very low. Then we have the visible light, which consists of 7 colors. There's the WebGyor, GYOR: violet, indigo, blue, green, yellow, orange, and red. There's the WebGyor, there's the visible light range, and then we have the X-rays and gamma rays. X-rays are highly energetic rays, part of the spectrum. These are the rays, there's the high energy, and then we have the gamma rays, there's the strongest energy, there's the most highest. Then we have the photon. So you have to know what is photon. A photon is a small packet of electromagnetic energy. The small packet of electromagnetic energy is known as a photon. An X-ray beam is actually made of millions of photons traveling from the X-ray tube to the patient body, is known from the quantum theory. So we have the X-rays or the rays are traveling in form of quanta, or there is the photon. Then we have the annual square law. You should know it. So the inverse square law states is the radiation intensity decreases as the distance from the source increases. For example, here we have the source of the radiation, and here this we have the ray. This is the ray we have here. So the radiation intensity decreases as the distance from the source increases, but it's the double, so the intensity decreases double or two times as the distance from the source increases. Here we have the source. For example, here we have the distance, this will be taken as d, and here we have the impact point, for example. So if from the source the distance is increased 5 meter, so the intensity will be doubled, decreased like 10. So this was inverse square law states. Here we have the square, inverse square law states this. If you move further away from an X-ray source, you receive less radiation. This was inverse square law states. Double the distance, radiation becomes 1/4. For example, if we have if we increase the distance by 1 meter, so the radiation becomes 2 times or 2x less or decrease. Then we have if doubles, so it's become 4 times, and so on. So that's the inverse square law. Like the square of the distance is equal to the radiations that decreases. If we take the square of the distance, so the radiation decreases that times. For example, if we have 3 distance, for example 3 times, so its square is 9, so the radiation decreases by 9 times. If we have 4, so 4 squares equals 16, so the radiation intensity decreases by 16 times. That's how inverse square law works. Then we have the X-ray tube. The X-ray tube is a component of the X-ray machine where electrical energy is converted into X-ray films. In the X-ray tube we have a filament like this tungsten filament, and then the current goes through this filament, and the electrons are ejected via thermionic emission. Here we have the electron cloud forms, and then these are caged or attracted toward the anode side. The anode is kind of this, like an inclined position, so to maximize the X-ray production. It contains a cathode and anode. Cathode is the negative and anode is the positive. Then the anode, why its name is anode? The anode is named like that this attracts the anion, and anion is a negative charge species, so that's why it's called anode. Electrons travel from the cathode to the anode producing X-rays, and when the anode is hit by the electrons, so X-rays produced. Cathode is a negative side of the X-ray tube that produces and controls electron. Explanation: it contains the filament where electrons are released by heating. Electrons are released by heating or thermionic emission. Memory cloud, that is the cathode, creates electrons. Then we have the anode, so its definition is like this. The anode is the positive side of the X-ray tube where electrons strikes and X-rays are produced. So that's the production side. Usually made of tungsten because it can tolerate high heat. The anode is made of tungsten. Why? Because tungsten cannot be evaporated easily, so that's why as the most convenient stuff to be used here. The anode is area where X-rays are produced. That's the production side. Then we have the line focus principle. You have to know that the line focus principle is a technique in which the anode target angle creates a small effective focal spot while maintaining a larger heat area. It gives better image sharpness and better heat handling. Then we have the Hill effect. So the Hill effect is the variation in X-ray intensity across the X-ray beam due to absorption of X-rays within the anode.